So we are in session 3 of Unit 6. Session 3, we are taking the topic coordinate geometry. So how to teach coordinate geometry. At the end of this session, you should be able to find the gradient of a straight line, equation of a straight line, and magnitude of a line segment. So gradient of a straight line, the gradient or slope of a straight line or line segment is the degree of its steepness or the rate at which it rise or fall. So the slope or the gradient is normally how it rise or how the line falls. Now, when we go to the next slide, that's what we are going to talk about. If you look at this line OA, its gradient implies that for every 3 units we move up, there's a corresponding 5 units down here. So our gradient is going to be 3/5. When you take OB for example, for every 2 units you move upwards, that's the vertical, there is a corresponding -6 units. When you look at the C, for every 2 units downwards, that's -2, there is a corresponding 5 units to the horizontal. So that's going to give us -2 over -5, and the negative take off each other. That's going to give us 2/5. So quickly, let's look at the next slide. So that's what we're talking about. The gradient of the line OA is 5/3. Why is it 5/3? Because we can interpret this as for every vertical upward move of 3 steps, there is a corresponding horizontal rightward move of 5 steps. So if you are moving right, then it's not negative. But when you are moving left, it's negative. So that's why on the line OB, the gradient is going to be 2 over -6, because we move -6, or we move to the left 6 times. And we solve this one. When we solve this one, we are getting -1/3. So that's why here we have -1/3 as our gradient of the line OB. Generally, if we have a point P1 and P2 are points on the straight line, the slope is determined by the change in the vertical direction, that's y2 minus y1, divided by the change in the horizontal direction, s2 minus s1. That's the figure over here. This point 1 and point 2. Each point 1 have s and y coordinate, point 2 has s and y coordinate. So the change in the y component over the change in the s component, that gives us our gradient. If we denote the gradient of a line by m, then mathematically we can write this one as m equal to change in y over change in s, the rise over the rad. Using algebra, the gradient can be written as this: y2 minus y1 over s2 minus s1. There are 2 special cases of gradients that we have to note. If a line is horizontal, then when the line is horizontal, line flat, then our y2 will be equal to y1. And in that case, our change in y will give us 0. When that happens, our gradient is always 0. That's when you are asked to find the gradient of a floor. The floor, you realize that the floor is a line on the ground, horizontal. The gradient of horizontal line is 0, yes. We observe that if a line is vertical, the s2 will also be equal to s1, meaning s2 minus s1 will also give us 0. In this case, we are going to have a number over 0. And we know that when the denominator of m is 0, the gradient is what? Undefined. Number over 0 is always undefined. So that's the gradient of a vertical line is undefined. This is why the definition of gradient includes the condition that S2 minus S1 should not be equal to 0, because the moment S2 minus S1 is equal to 0, our gradient will be undefined. And practical example is the gradient of a wall, a vertical wall. Rather, a vertical wall is straight. In that case, the S and the S2 and the S1 are always the same. So that means our gradient there will be undefined. Now we come to equation of a straight line. The relationship that can be represented by a straight line graph is called a linear graph or a linear relationship. The linear relationship can be represented by an equation which may be written in the form in different forms. So you consider two of these forms. Equation of a straight line given its gradient and a point on the lines. So this is one of the forms to find equation of a straight line. Suppose we are given the gradient m of a straight line and the point P, and our point is S1 Y1 on it. We can guide our student to find an arbitrary point P on that same line, then we use it to find our grade. So let's move. When we look at our figure that we have here, the gradient of the line M is, so in this case we are saying this is the point on the line, and we have created arbitrary points with S and Y as the coordinates. So in this case, we are just going to have our gradient to be, or our Y component to be Y minus Y1, and our S component will be S minus S1. Therefore, our gradient is going to give us Y minus Y1 over S minus S1. When we cross multiply, this component will multiply the M component. So that's going to give us Y minus Y1 to be equal to M into bracket S minus S1. And this is the formula for finding equation of a straight line. So we use this formula when a gradient and one point is given to us. So let's go and take example and look at how we are going to apply them. Now, ask your students to use the formula to write the equation of a line with gradient this. Gradient is 2 over 3 and pass it to the point 6, 5. So our solution is that our M is 2 over 3, S1 is 6, this is the S component is 6, Y component, that's the Y1 is also 5. So we'll just do substitution into the formula, and that will give us Y1 which is 5, M which is 2 over 3, S1 which is 6. And when we clear the fractions, we have this as an expression. We group all of them at one side, we simplify everything there to be equal to 0. So this is the final equation of our line, and this is in the form of AS plus BY plus C equal to 0. And that's the general form for writing equation of a line. So suppose we have equation of a straight line passing through two given points. Then our point A is S1 Y1, our point B S2 Y2. This is shown down here with this figure 8. Now we know how to find the gradients of these 2 points P1 and P2. These 2 points, you can easily find our gradients from the known. We know our gradient is Y2 minus Y1 over S2 minus S1. And from the previous slide, we said that the equation of a straight line can also be given by this. Y minus Y1 equal to M into this. So when we substitute our gradient M over here, this is the expression we are going to get. Y minus Y1 to equal to Y2 minus Y1 over S2 minus S1 into bracket S minus S1. That's substituting our gradient into the equation of a line formula. And that's going to give us this expression. When we divide both sides by Y2 minus Y1, this is what we are going to get. And this is the expression that we're going to get. So this, the formula we can use when we have two given points given to us to find the equation of a straight line. So this is a question. The points here is 2 and 3, 2, 3, and 4, 7. So our solution will be that S1 is 2, Y1 is 3, S2 is 4, Y2 is 7. So by way of substitution, this Y minus Y1, we're fixing our Y1, which is 3, Y2 is 7, Y1 is 3, S2 is 4, S1 is 2. We come and fix our S1 again, 2 here, and we simplify, we expand whatever we have to get this expression. Then we simplify it to give us y to be equal to 2s minus 1, or writing the general form, pushing everything to one side. That's the as plus by plus c equal to 0, that form. So this is what our solution should look like. The magnitude of a line segment. To find the magnitude of a line segment is to find the distance between the endpoints of the line segment. So you can guide your student to derive the formula for finding the magnitude of a line joining 2 points. Suppose we are given the line segment with this endpoint P, S1, Y1, and Q, S2, Y2 as shown in this diagram. That's the P, and our Q is this. What are you going to get its magnitude? That's the length of the line. So let's look at the next slide. So triangle PQR is a right angle triangle. So using Pythagoras theorem, you can see the length for PQ square will be equal to PR square plus RQ square. And the PR, that's the difference between the S component, the difference between the Y component, that will be the RQ, difference between the Y component. So therefore, the length, that's the hypotenuse, the side facing the 90 degrees, is going to be square of that to be equal to root of, square of this will be equal to squares of these shorter ones. So when we take square root to both sides, our distance D will be equal to square root of S2 minus S1 square plus Y2 minus Y1 also square. So difference between the S component and difference between the Y component. And as you square them, you square both of them, you take their square root to get your answer. So this is a question. Find the shortest distance between the points A and B. You just do your substitutions there. So difference between the S components, you have 7 and 3. Difference between the Y component, we have 12 and 9. So that's going to give us 4 square plus 3 square. That will give us square root of 25, which is 5. That brings us the end to this session, and we have learned about coordinate geometry, how to find the gradients of a straight line, equation of a line, and magnitude of a line. Thank you.